Hi everyone, welcome back to my channel. Today in this video we are going to discuss the topic of electrochemistry in conductometric titration of acid-base titration like weak acid and strong base. In the previous video we discussed strong acid versus strong base. Here we can see that weak acid and strong base. Conductometric titration is a titration to measure the amount of analyte present in the given solution by measuring the change in the conductance as a function of volume of titrant. Conductance is mainly due to the movement of ions in the solution. One ion is replaced with another ion of different ionic conductivity during the titration. Equivalent point is determined by graphically. We can take the example of weak acid and strong base. Weak acid is acetic acid and strong base is sodium hydroxide. Acetic acid is a weak acid, it does not dissociate easily. Weak acid is an analyte. Here sodium hydroxide is a titrant which is taken in the burette. On reaction between the acetic acid and sodium hydroxide we get sodium acetate. Sodium acetate is an electrolyte. It will be better dissociates than acetic acid. It will be represented as ions. H plus and OH minus ions are high ionic conductivity and Na plus ion are low ionic conductivity. Before we starting the experiment, we know the few facts, that is we are going to determine the amount of acetic acid present in the given solution. So the acetic acid is a weak acid, it does not dissociate easily, so cannot represent the ions. Whereas sodium hydroxide is strong base which dissociate immediately, it will be represented as Na plus and OH minus ions. Addition of sodium hydroxide to acetic acid, some amount of sodium acetate is formed. Due to common ion effect, slightly fall on the conductance. And adding sodium hydroxide to acetic acid, it gives sodium acetate. It will be better dissociate than acetic acid. In equivalent point or neutralization point, all the acetic acid will be reacted with the sodium hydroxide. Only sodium acetate and water are present. After the equivalent point or neutralization point, excess addition of sodium hydroxide, that is the accumulation of OH minus ion with the high ionic conductivity, so the conductance increases drastically. Here the graph is drawn between the conductance and volume of sodium hydroxide. We get the two straight lines. By trapping the two lines or intersection, we have to take the value is the volume of sodium hydroxide. This value is the concordant value. Next we come to the practical section for acid-base titration of in the case of weak acid and strong base. Weak acid is acetic acid and strong base is a sodium hydroxide. The aim of this experiment is to determine the strength of given acetic acid by conductometric titration. The requirements of this experiment: acetic acid, sodium hydroxide, 50 ml burette and 20 ml pipette, 100 ml beaker, glass rod, conductivity meter with cell. Here the procedure for conductometric titration of weak acid and strong base. The given acetic acid is transferred into a clean 100 ml standard flask and made up to the solution up to the mark using distilled water. 20 ml of this solution is pipetted out into a clean 100 ml beaker and adding 30 ml of conductivity water. Conductivity cell is completely immersed in the solution. Every addition of sodium hydroxide solution of strength 0.5 N in the portions of 0.5 ml, the solution is stirred well and allowed to attain equilibrium. Then see the conductivity of the solution between the two electrodes because of the movement of positively and negatively ions of the opposite electrode. The conductance will be noted. Acetic acid is a weak acid. It does not dissociate into ions. And addition of sodium hydroxide to acetic acid, some amount of sodium acetate is formed. Here we see that due to common ion effect, acetic acid does not dissociate easily and slightly fall in the conductance initially. After the addition of sodium hydroxide during the titration till the equivalent point or neutralization point, sodium acetate is continuously forming as adding of sodium hydroxide. We know that sodium acetate is better dissociate than acetic acid. So the conductance is slightly increases. It is not drastically increases, slightly increases till the equivalent point. In equivalent point, all the acetic acid is reacted with the sodium hydroxide. We got only sodium acetate and water. After the equivalent point, excess addition of sodium hydroxide, we don't have acetic acid. Accumulation of OH minus ion with a high ionic conductivity as the conductance increases drastically. Here, the every addition of 0.5 ml portions of sodium hydroxide, the conductance will be noted. By tapping the two lines or intersection, we have to take the value is the volume of sodium hydroxide. This value is a concordant value. The volume of sodium hydroxide is the complete neutralization of acetic acid. So, volume of sodium hydroxide we get from the graph, and strength of sodium hydroxide is 0.5 N and volume of acetic acid is 20 ml. From this value, we can calculate the strength of acetic acid present in the given solution. I hope you like this video. Share the video, watch the videos and subscribe the channel. Until we will meet another session. Bye bye. Thank you.